Hi everyone, welcome to this Symetri video where I'll be showcasing some of the new features and benefits of Revit 2022 for structures. Following a similar theme from last year, the main efforts have been focused on reinforcement improvements and new features, as well as some new and improved tools when working with steel connections. However, this release also has some very useful platform tools that will benefit all users of Revit. I will showcase some of these tools which will streamline your drawing outputs and improve some general areas of Revit. I must say that it's great news to see Autodesk focusing on the day-to-day operation of Revit and some of the core tools to improve things such as revisions, 3D grids, PDF naming and tagging. These are things we all rely on a daily basis. Let's start by taking a look at the new improved tools relating to structural connections. Revit now ships with just over 130 steel connections and gives us the ability to create custom fabrication elements to generate our own types of connections. To assist with the efficient choice and modelling of connections, Autodesk have created a new tool that allows the user to set ranges of applicability. This feature essentially allows you to create a library of standardized steel connections that can be placed automatically based on a number of different parameters such as geometry, the section shape, materials, and member end forces. The standardization of connections, particularly simple connections as found in multi-story braced frames, is an essential process for the control of costs. The cost of steel connections can be greatly reduced if they are based on standard details, which in turn reduces fabrication and detailing costs. Your connection library can be created in an external Revit file and then referenced when placing the steel connections. The automatic placement of connections can then be implemented with the use of some pre-created Dynamo scripts. These can be run through the Dynamo player for those of you that are not Dynamo users. So let's go ahead and start up the Dynamo player. And then we'll actually place out some base plates based on a pre-created Dynamo script. So you can see that Revit 2022 comes armed with a number of different Dynamo player scripts that we could use for the placement of steel connections. In my example here, I'm going to place out base plates by ranges. So we can click on Edit Inputs here, and the first thing we'll need to do is make a selection set of the entire model. The Dynamo scripts will automatically filter out the relevant elements, which in this case are just the columns. If the columns aren't vertical, we can configure slant angles and so on. And as I said earlier, if we are using an external library to store our connections, we can then browse out to that library. But this is ready to now go, so I'll select Play, and then the Dynamo player will add the various different base plates based on ranges of applicability. Okay, so you can now see we have a summary report, and also we have our base plates placed out. So if we rotate around the back of the structure here, you can see that we have different section sizes for columns. And of course, you'll notice here that the ranges of applicability have managed to actually place out the correct base plates based on the geometry. So how does this all work? Well, let's close down the Dynamo player and we'll select one of these base plates. I'll select this one here, for example, and then I'll edit the type of connection. So in the Type Properties dialog, you can now see that we have Modify Ranges of Applicability. And if I select this, you can see that obviously a column only has one element, but if it was a beam to column connection, then we'd have two tabs here, Element 1 and Element 2. And essentially what we can do is, in this case, you can see that I've added in the size of the base plate. So here I've got a 500 by 500 by 30 base plate here. And then I'm able to say, well, okay, based on a family and section name shape, using universal columns, I can use these two columns with this dimension on the base plate. Now I could further enhance that by making sure that I select a particular material that I might want to use for ranges of applicability, as well as member end forces. Let's have a look at some other examples. So I'll cancel this one. And we'll go ahead and select another base plate. So we'll perhaps pick this one here. Once again, we'll select Edit Type. Again here, you can see I have Modify Ranges of Applicability. And in this case here, you can actually see that I've got three different base plate types that I could use here. And you can see I've got one for universal columns, and these two elements are applicable. Then I have one for square hollow sections, and this particular square hollow section is applicable to that same base plate size. And again, for the same base plate size, I have one for a circular hollow section. So this is really useful. This allows us to standardize these connections and obviously place them out automatically using the pre-created Dynamo Player script. So let's now look at the next new feature relating to steel connections. If I zoom in to one of these particular base plates here, and generally you'd have found with previous releases that the material on the base plate and things like profiles was fixed, and then we'd have to go back and individually change each plate. Well, they're now configured to using by category. So if I go to the Object Styles tool up here, and we then go ahead and find our structural connection category, you'll notice here that we can actually set now the default material for plates and profiles. So for example, if I go to my S275 connection plates material in here, so perhaps here I want to use this material, so I can click OK to that, click OK again, and you can now see all of the base plates or plates around the whole project have now changed to use that new material. So that's a nice little improvement when you're wanting to improve the consistency of materials within plates and profiles. Whilst we're in this model, we'll actually have a look at a couple of platform features as well. You've probably all noticed that I'm displaying 3D grids in this view. This is something we've been waiting for many years in Revit. The only alternative to this was to use a Dynamo script to place out the grids or just have a DWG file that's displayed in the background. But of course, none of that was ideal. So these 3D grids now work and respond very similar to levels that were implemented a couple of releases back. The good thing with the 3D grids, just like the levels, is that you can stretch them and change the extents of the grids from within the 3D view. Of course, you can also edit the grid in this view as well, so you can change the grid reference and the number, you can hide or show the bubbles, just like we would do in a 2D view. Another interesting thing here is you can see that we've got grid 5.1 at the back here, and you'll notice that the text is projecting through the model, which helps us visualize that a little bit better. Of course, if you want to switch this off, you can just go into normal visibility graphics here on the annotation categories and then go ahead and switch off grids. We'll also now look at some tagging. So you can see here I've got a plan view set up just showing some SFS details here. And what I'd like to do is actually tag out these elements here. So I'll go to the Annotate ribbon and select Tag by Category. Of course, I can place out a tag over here. But you'll notice now we have a brand new tool up on the ribbon here that says Add Remove Host. So now I can start to pick other elements in here and you'll see we have multiple leaders being placed out. Okay, so once I've got that, I can select Modify here just to release the command, and then I'll reposition the tag somewhere nicer. So we can just move the tag, maybe down here somewhere. And I'm going to now change the tag type. So here I'll just actually have a 90-degree one. And you'll notice here that we're now calling up the quantity of elements that we've picked. So by adding or removing hosts in here, we also have a function when we build out the tag to actually have Revit count those number of elements. Now, of course, you'll notice here that I've got a member here that's back to back, and of course I've forgotten to tag that one. So up on the context ribbon here, I could say add or remove host, pick this additional one in here, and of course you can now see the count updates. So that's incredibly useful. If you accidentally pick something that's not part of these same family members, so if I pick this column over here, then you'll notice we get varies in there. Okay, so again, it's quite useful just in case we pick a different element by mistake. Okay, so there's another platform feature that I think all of you will find useful. Let's now take a look at some new and improved features relating to reinforcement and detailing. Year on year, Autodesk continue to build out a better platform for the modelling and detailing of reinforcement. In Revit 2022, we now have the ability to model rebar at its real diameter. Previously, the rebar was modelled to its nominal diameter. For example, a H25 bar has a nominal diameter of 25 mm, but a real diameter of 29 mm. This is useful when you have high levels of congestion and a large amount of steel in particular members. If you have a number of different rebar layers, then the real diameter ensures that the steel that you detail can actually be fixed out on site without any clashes or congestion. Let's now take a look at this feature. I'll select one of these reinforcement bars on screen, and here I'll select Edit Type. You'll notice that if we look in the Type Properties dialog box, we have the bar diameter, which is its nominal diameter, and you can see that's set to 20 millimeters, but now we have this new function of model bar diameter. And of course, if we wanted nominal diameter, we could type in 20 there, but you can see that out of the box by default, this is set to the actual real diameter of the reinforcement bar. So that's a very useful feature. We can also see here that we have a drainage pipe going directly through the reinforcement here. Now, of course, you can clearly see there's a clash. So in previous releases, we'd have to physically move the rebar set, or if that wasn't possible, we'd have to split the rebar set and have a rebar set on the left-hand side and then another rebar set on the right-hand side. Of course, the problem with that is when you come to schedule the reinforcement bar, they'll be in two separate ranges. And also, when we come to detail it, we'll have to put down two multi-rebar annotations. So we now have the ability to move individual rebars in a rebar set. So I'm going to select this rebar set here. And if we have a look up on the context ribbon, we can see we have this new feature called Edit Bars. So I'll select Edit Bars, and you'll note here that we can now modify the bars. So I'll select this bar here, and then I'll rotate the view a little bit. And this particular bar is actually clashing with the pipe. So what we can do here is use this temporary dimension, and then type in a dimension, and you'll see that link then moves. I'll do the same thing for this bar. Again, we'll set a dimension here, and you can see that link is now clear of the drainage pipe. And finally here, I'm going to select this one, and this one I want to completely remove. Now notice here that currently I've got a rebar quantity of 41 elements. So if I now remove this bar, of course you'll now see that when I select the bar again here, you can see we've now got 40 elements. So Revit's taken into account, and it's not simply just hiding this bar, it's actually removing it from the rebar set. Now, of course, you'll notice up on the ribbon here, as well as being able to physically move the bars, we can also rotate them as well. So if it was appropriate, I could actually rotate one of those links just to clear another reinforcement bar. But I'm happy with this, so I can select Finish now, and then we can inspect our change. So now, if we orbit and rotate around the drainage pipe here, we can clearly see that we've now got a clash-free model. Now what's quite important here is if I now go ahead and open up the ground beam elevation here, you can now see the same arrangement of rebar. I'll select this rebar set, and what I'm going to do here is now put a range indicator on it. Now before I do this, I want to edit the display of the rebar set. So here I'm going to select none. I want to show the start bar, the end bar, these two bars here, and then these two bars here. I'll then select Finish. And now we can put our MRA across this rebar range. Of course, here you can now clearly see that we've been able to call up all the reinforcement bar in one operation here. And of course, you can clearly see now we have a dimension here displaying the rebar sets that need to be moved. Okay, let's switch back to the 3D view. Now, when you do have overrides to rebar sets, it might be useful to actually see where those overrides have actually happened. So we can actually set up a view filter to actually show us if a rebar set has been edited. So I'm going to go into Visibility Graphics here. I'll click on Edit New to create a new filter. And here we'll call this one Rebar Set Edit. From the category section here, we can now choose Structural Rebar. And then you'll notice here that we can actually select Modified Rebar Set. And then here, I'm going to say equals yes. So there's our new filter. We'll now add that in. And then if we override the color, so let's make it green in here, and perhaps we'll make the pen a bit thicker as well, and apply that filter, we can now clearly see highlighted in green the rebar sets that have actually been edited. Now let's imagine here, as the design moves on, we need to actually drop that drainage pipe down. But of course, then that means that we can actually have a uninterrupted rebar set again. So I can select the rebar set, and up on the context ribbon, I can simply reset all of my edits, and it will revert back to its default arrangement. And of course, you can now see that the filters reflecting the fact that the rebar set has not been edited. So again, a really useful tool there. And of course, we can use that in all sorts of different examples. You can see I've got another example here where I'd need to actually just move one of these rebars. Other examples will be if you have bigger diameter rebars and they're both clashing with each other. Again, you could align two rebars or move them slightly. So that's a very welcome addition to reinforcement. Okay, so next we'll have a look at a new method of placing rebar by 2 points. So I'm just going to switch to a cross-section view here, and you can see that we have a beam on the edge of a slab here, and I already have the main reinforcement placed out. What I want to do now is create a link. So I can select the rebar command as standard, but now you'll notice that we have two different placement methods. We have the default method that was used in older releases, which was expand to host. So in this case here, I'm going to choose shape 51. So let's go and select that. Of course, if I pause over the element here, you can see that the shape expands to the cover of the member. Notice also that I have a nice tooltip here. It's telling me here that if I press space, I can flip or rotate the bar around the element like this, or I can press shift to lock the orientation of the face. Those tooltips can be controlled up here with this simple little on or off button. So if I turn it off, of course, I don't get any tooltips or feedback, but it's quite nice to have that on. Okay, so what I'm going to do here is place out this standard link. As I've said, it will expand to the host, which is the default method of placing rebar. But now here we have this new method by 2 points. So I'm going to select that and I'm going to place another link. So this time I'm going to place the link over here, so I can pick a start point and then an end point, and you can see how simple it is to then create that new link. Let's have a look at another example of that. I'm going to switch here to a plan view. And if we zoom out here, we can see that we have this main area of reinforcement here, and I have some piling underneath this slab. What I want to do is just place in some extra reinforcement on the bottom layer. So I'm going to also do this with the new 2-point method. So I'll select rebar. Once again, I'll make sure that I've got the 2 points selected here. I want to place this on the far face, so basically on the bottom of the slab. And you can see here that I have two methods. I can use horizontal placement or vertical placement. So in this case, I want horizontal placement. And then I'm just looking for some straight bars, so I can select shape code 00. And then here, I'll select H25s. Of course, up here, I can set my spacing. So I want number with spacing. I'll have a spacing of 250. And in this case, I'm looking for 5 bars. And then I can start to create my shape. So I'll start here. And you can now see, simply by picking 2 points, I can place out all of that rebar. And you can see it's real easy to do. So we'll place out another one over here. Again, nice and simple. Now, another method we can use is to place vertical bar by picking 2 points as well. So if I go back to select rebar again, you can now see that if we've got a shape code selected that is a straight bar, so 00 or 01, when I'm in the 2-point method, I get this additional feature here to place bar perpendicular to the segment. So what would happen here if I wanted straight bar, I could simply pick 2 points, and you can now see that I can actually then model those bars in. Of course, the number of bars is constrained up here because currently I've got number with spacing, but I could change that layout rule. I could say maximum spacing here, 250, and now of course the range will obviously expand as I move my cursor around the model. So again, another really useful method to place out rebar. Let's now take a look at tapered walls. Tapered walls follow on from last year's implementation of a slanted wall. The difference here, of course, is we can vary the thickness of the wall. So let's first take a look at the wall type. So we'll select this type here and click Edit Type. And then I'll go and edit the structure of this wall. You'll notice here, very much like a floor, we can introduce the variable option. And this will allow, of course, the thickness to vary. The thickness set here will be the top of the wall. So let's now see how this feature works. If I zoom into this wall section here, you can clearly see that it is tapered. And if I select the wall itself, you'll notice here currently I have a 5-degree slant or slope angle. If I click on this and I want to increase that, I can just type in perhaps 8 degrees. Of course, you'll see all the rebar updates, and of course the wall's got a bit thicker. As well as typing in values, I can just use the shape handle to actually change the slope as well. At present, you'll see that I've got a slope on the back face of the wall, but if I wanted one on the front face as well, you can see in the properties palette here, we can also access the exterior angle or the interior angle. So if I wanted a triangular section for my wall, I could put a slope angle here, and you can now see that section's updated. Okay, let's return that back to 0. So clearly this feature is intended for things like retaining wall structures, as you can see here. And of course we can use our freeform rebar to actually reinforce the wall. Okay, so that concludes the new features of Revit 2022 for structures. Thanks very much, and I'll speak to you soon.